Welcome to another episode of WaveFEA tutorials. This is your host Mac, and today we're going to talk about the method to set up nonlinear static analysis for hyperelastic materials. Let's take an example of rubber, whose stress-strain relationship can be defined as nonlinear elastic, isotropic, incompressible, and generally independent of strain rate. Hyperelastic material is still an elastic material, which means after the removal of forces, it will retain its original shape. It's also a Cauchy-Elastic material, implying that the stresses are determined by the current state of deformation and not by the path or history of the deformation. Hyperelasticity provides a means of modeling the stress-strain behavior of such materials. Let's jump right into the tutorials. The model chosen here is the cut section of an O-ring which is subjected to displacement at top plate. Let us now change the units of measurement to English system. We can now define the material properties for the top and the bottom plate. In order to do so, click Material button on the Command Manager, scroll down and select the material to AISI carbon steel. Rename the material as rubber for O-ring, select type as hyperelastic and subtype as Mooney-Revlin. Enter the first and second distortional constants of shear deformation as 2100 and 8400 respectively for A01 and A11 under the Hyperelastic tab. Click OK to confirm. The idealizations can now be defined. Click on the Idealizations button on the Command Manager, enable the checkbox for associated geometry, select the top plate as well as the groove, and ensure that the AISI carbon steel is selected as the material property. Similarly, add idealizations for the O-ring and ensure rubber is selected as the material. As the model is asymmetrical, let us define the coordinates for the system as cylindrical. Click Coordinate System under the model tree, select New and change the type to cylindrical. Click OK to confirm and view the cylindrical coordinate system. Let us now define the mesh details. Click on the mesh model to open the mesh settings, launch the mesh table, enter the mesh sizes as follows. Groove and top plate as 0.07 inch, the rubber O-ring and the global mesh as 0.04 inch. Ensure that the element order is chosen as linear for the O-rings. Finally, right-click on the mesh model and generate the mesh. Now that the mesh is generated, we can add the constraints to the model. Click on the constraints in the Command Manager, rename it to Constraint Z Direction, select the Coordinate System 1 under the Coordinates section, click on the Free button and enable the TZ checkbox. Select the top face and bottom plate of the groove in Z direction. Now click on the Duplicate button and revise the name to Constraint Theta Direction. Ensure that the Coordinate System 1 is selected under the Coordinate System. Click on the Free button and enable T-Theta checkbox. Select the symmetric side faces of the top model in both the sides. Click on the New button and revise the name to Constraint R Direction. Ensure that the Coordinate System 1 is selected under the Coordinate System. Click on the Free button and check TR checkbox. Select the inner and outer radial side faces of the model. We can now define the loads. To do so, right-click on the loads under the browser tree, change the name to 25% loading, select enforced motion under type and displacement under subtype. Ensure that the cylindrical coordinate system is selected under the coordinate system. Then select the top face of the top plate under selected entities and set the magnitude as -0.014 in TZ direction. Follow the same procedure to create the loads for 50%, 75% and 100%. And set the magnitude as -0.028, -0.042 and -0.056 in TZ direction respectively. Let us now create the subcases for the defined loads. Edit subcases in the WaveFEA tree, revise the name to 25% loading. Ensure only load 1 is selected under the loads menu while all the constraints are selected under the constraints menu. Follow the same procedure to create subcases for 50%, 75% and 100% loads. We can now apply the manual contacts. Click on the manual contacts on the command manager, select the bottom surface of the top plate as master entity and the top surface of the groove as slave entity. Set the max activation distance as 0.1 inch. Click on duplicate button and change the slave entities while keeping everything else as it is. This will create contact between top plate and O-ring. Let us now define the contact between O-ring and the groove. Select all the faces of O-ring, select the groove face as master entity and select the O-ring face as slave entity. Set the max activation distance as 0.07 inch. We can now change the setup to non-linear analysis. This can be done by opening the Analysis 1 menu under the WaveFEA tree and ensuring that the large displacement is on in the Options tab. Under Non-Linear Setup 1, ensure intermediate output is on and enter the number of increments as 25. Under Advanced Settings, select the convergence criteria to work, click OK to confirm. Make similar changes to Non-Linear Setup 2 as discussed for Non-Linear Setup 1. Under Non-Linear Setup 3, ensure intermediate output is on and enter the number of increments as 25. Under Advanced Settings, select the convergence criteria to work and set it as 0.02. Click OK to confirm. Make similar changes to Non-Linear Setup 4 as discussed for Non-Linear Setup 3. We are now ready to run the analysis. Right-click on the free space on the WaveFEA tree and click Solve in Nastran. Once the analysis is complete, click on Results to view the displacements and stresses for each increment across all the subcases. In this tutorial, we have learned method to set up non-linear static analysis for hyperelastic materials. Thank you so much for joining us today. This is your host Max signing off. For more information, visit our website www.wavefea.com. You can also opt for a 30-day free trial of WaveFEA software on our website. We will be back with more features and updates from WaveFEA. Thank you.